In this video we're going to look at how we can use some of the old constructs of things like if statements to start creating and moving towards what would be a block breaker type game. So how are we going to do this? Well, so far we've got this code which just uses two subs which we're actually not executing that we need to do. One that sets up the graphics window and one that just draws a circle. So if we just run those two subs, set up graphics window, and we need to create the circle. Sure enough, we just create the circle in the center of the graphics window. So what I'd like to do now is see if we can make the ball move across the screen, and when it hits this edge it bounces back and comes back across the screen. So we're going to first of all make something that moves the circle. Now I want it to forever move the circle, so hopefully you can figure out that we're going to use a while loop, while 1 equals 1, and I'm going to say while 1 equals 1, we're going to change where we plot the circle. Now at the moment we draw the circle at this location to get the center point. I'd like to start plotting the ball's x and y position, so I'm going to create a new variable called circx, and we'll use this to set its starting location, which is just finding that middle point for us. And we'll store that. And we're also going to have circy, the circle's y position, and we will use this to store its initial value when we set up the graphics window. Now I've just realised that I don't like that that's in the setup graphics window because it's not actually setting up the graphics window. So instead I'm going to suggest that we take that out and maybe put it inside the creating the circle. It makes more sense to me. And then in our actual where we want to move the circle to, we can now simply say we want to move it to circle X and circle Y. So we haven't done anything different, we've just taken out these two bits that we'd coded previously and replaced them in our move method and just put them as the variables in there, so you can see where it's being pulled from. Just to make sure that that's running exactly the same as it did before. Oh, I started writing my while loop and I didn't finish it. So why don't I just comment that out for a second, just so I can test to make sure the game is working as expected. Yeah, it's working just as it was. That's good news. So with our while loop, I'm going to say while 1 equals 1, let's move the shape. Shapes dot move, and I want it to move the circle, and I want it to move it to, well, the circle's x position and the circle's y position. Now actually this is the exact same line of code as the one that we used in here. So at this point, because circx and circy never change, it's just going to constantly move the circle to the starting location, which is just doing a lot of processing but not actually doing anything else. So instead we could start changing circx as we loop through our while loop. So why don't we say circx equals whatever circ used to equal, circx used to equal plus 1. So each time we go around this loop, we're changing the value of circle x. Let's run that and see what happens. Whoa, ball flew out the screen too fast. Let's go and put our delay in. Program dot delay, and let's just give it a delay of 100 milliseconds. This could go too fast, too slow. We just need to play it around with the values until we're happy with how the ball's moving. Okay, so that's moving. That's really good news. Possibly a little bit slow for my liking. I might delay by a smaller value. Let's just say 50, so it goes twice as fast as that. Maybe even 20. I don't know. You can play around with the values as you choose fit. So the only problem we've got at the moment is that when the ball gets as far as the end, it's just simply going to keep moving, and it's going to go outside the bounds of the graphics window. And if we were to comment out the line of code that says we can extend a graphics window, we could extend it out and actually see the ball being plotted all the way along here. So let's write a bit of code that would allow us to make the ball check to see if it's hit that side. And I'm going to create that using a new sub. I'm just going to call this sub check edge. So I'm going to say if, now what do I want to check? Let's have a look at this in a diagram. So this is the ball that we're moving. I've put a square around it so you can see that actually the ball is being plotted from the blue circle drawn here, and that's actually the coordinate that's being plotted. So what I'd like to look at doing is when the ball moves across the screen like so, it'll eventually get to here where it collides with the wall. So what do I need to check to see if the circle's x position, and now remember the circle's x position, which is being the x coordinates going along here, is being plotted at this point here. So it's not being plotted at the edge here. To show you what I mean by that, we could do something simple like if circle x, so the x position of the circle, is greater than the edge of the screen. Well, we know what the edge of the screen is, and this is where our old variables are so useful. I know that I set up the graphics window's x position, so it's 634. So if our circle x position is greater than 634, then let's say that we want to move the ball back the other way. That's going to be quite tricky. Why don't we just tell it to move the ball back to the centre position? Why don't we just recreate a new ball back at the starting point? So to do that, I could just run that sub just for now. So create circ. It's quite nice again seeing how because we've created a sub, that we can use that tool to just recreate that ball. And of course, when we run that sub, it draws it back at the starting point. So if the circle's x position is bigger than 634, sorry, we'll end that sub. Notice we've got two-tier indentation here, so we've got our sub, and because all of this is in our sub, it's all indented 1. And because this create circ is within the if statement, it's indented within that if statement. So let's just see if that code works. Oh, wait a minute. We never actually call this sub to make it happen. When do we want to check to see if we've touched the edge? Well, actually we want to do it every time the ball's been moved, just to check to see if it's on the edge yet. So why don't we run that in here just before the delay? I'm always going to keep the delay at the very bottom. So let's just say check edge. So it will move the shape to the normal position, it will increase the x value, check to see if it's touching the edge, and then it will move the shape again. Let's see if this works. So sure enough, the ball moves across the screen, slightly jittery again because I'm running Windows on a Mac, and my Mac's not particularly fast. And it gets past the edge, and sure enough we created a new ball. Notice the old ball actually does stay there. But the point is, it's actually creating the ball. I want it to create it as soon as it touches the edge, but it's actually creating it when the x position, i.e. the left-hand side of the ball, touches the x. So how can we go about correcting this? Well, if we go and look at our diagram once more, we really want it to be when the x position is greater than, well, actually no, we don't want the x position. We want the x position plus the width of the circle. So if that's the x position, we want that plus this distance here, and if that's bigger than 634. So let's go and test that out. So if, where's our if statement? If circ x plus the width of the ball, which I believe we've got stored in a variable again, circ size. And again, the beauty of having all these variable names and these numbers created is, it doesn't matter if I go and change those and decide I want a bigger ball later on, all of this will work just as it does now. If I was still writing in the ball's width as maybe 50, and then I wanted later on to change the size of the ball, I'd have to change it all the way through my code, whereas with this, it's all just done automatically. Let's see now if the ball is recreated when it touches the edge. Should probably make my ball move a bit quicker. Fantastic. One other point is, why did I choose greater than 634 and not equal to? Well, actually the ball will never land exactly on 634, most likely. That's because in fact it's quite possible it will, because we're moving one pixel at a time. However, I've decided to move 3. There's only a 1 in 3 chance that I'll land exactly on 634. So I've just said, whenever your X position has gone beyond it, then we'll do the create circle. So equaling can be problematic in itself. So I don't actually want it to create a new circle. I'd like it to bounce and go the other way. Let's set this back to 1, and I'm just going to make my delay even less of a amount. So why don't we have something that says, if we do go over the edge, then we want to change the direction the ball goes in. Well, what chooses the direction the ball goes in? Well, it's this line of code here. This is the bit that is adding on to the coordinate of which we draw the x, and we're adding 1 to that coordinate each time. Here's an idea. Why not, instead of having 1, why don't we have a new variable set up called, let's call it, maybe when we create the circle we'll call this circ direction. We'll just create it at the top of this sub when we create the circle itself. So circ direction equals, and I'm just going to set it to 1 to start with. Well, that's not going to change anything if I just change this value in here to be circ direction, because that of course just equals 1. What the beauty of it now is that I've given it a variable name, is that I can change the value of circ direction, and that will allow me to modify my code so that it might go the other way. So let's have a look at that. Circ x plus circle size is greater than 644. Then let's change the direction of circ direction. There's a couple of ways you could do this. You could say, if circ direction equals 1, then circ direction now equals -1. Else circ direction equals 1. So we could just use an if statement to say, if it's 1, change it to the other. Alternatively, we can use a simple bit of maths, which took me a little while to get my head around. Circ direction equals, and this is just a useful maths tool, whatever circ direction was times by -1. What does this do? Well, when you times anything by -1, it just gives the inverse of itself. So if you were to times -5 by -1, you'd get 5. Do it again, you get -5. Do it again, you get 5. So it just switches whether it's a negative or a positive value. So timesing anything by -1 just switches its value, which means that circle direction, rather than being 1, will be -1. So if we run this one last time, and then we'll just talk about how the code's actually running. Ball hits the edge and bounces back the other way. Again, a bit blocky on my Mac. So at the moment the ball doesn't come back the other way, so I'm going to leave you to have a think about how you could add to this sub-check edge to see if it's touching the other edge. But just to run through what this while loop does, it moves the shape to wherever circ x and circ y are. It moves it in a certain direction, so it changes the value of circ x so that circ x is changing each time, so the circle's x position. We then check to see if it's touching the edge, and of course if it is touching the edge, we change the circle's direction. When you come to code this, because some of you will want to extend to use y as well, we probably need to change this value to be circle x direction, the direction in which it's moving along the x-axis, and I'm going to do that in here as well, because you might later on decide, and we'll have to change it up here, in here as well, that you're going to have that y direction. So is it going up or down using 1 or -1? But hopefully this gives you an idea of how you can make a ball bounce around the screen.